This is a video that's going to review the fundamentals of functions, what it means to be a function, domain, and range. And in the second part of the video, we're going to talk about how to evaluate functions or solve equations that involve functions from graphs and tables. So in this first part of the video, we're going to talk about how to look at a table or a graph, first decide if it's a function, and then whether it's a function or not, even if it's just a relation, we can state the domain and range of either the function or the relation. The first thing you want to remember is that a function is anything that satisfies the condition that each input produces only one output. So if I look at table A and I consider the x values the inputs and the y values the outputs, then when I look at my inputs, I see that -1 produces an output of 1, 4 produces an output of 2, -1 also produces an output of -3, and 0 produces an output of 1. So in this particular case, right here you can see that an input of -1 produces two separate outputs, so this is not a function. If I look at example B, I see -1 produces an output of 1, 4 produces an output of 2, 1 produces an output of -3, and 0 produces an output of -1. And I don't have any input that's producing two separate outputs, so this is a function. And while I'm still working on the tables here, let's talk about domain and range. Domain is a name given for all of the possible inputs, and range is the name given for the set of all outputs that are produced. So if I'm looking at my list that I have here, these items here are in the domain, and these numbers here are in the range. And when you just have a small list, we usually write them in set notation using curly brackets. You can technically write them in any order. I usually write them from smallest to largest. So the domain in A is -1, 0, and 4, and the range is -3, 1, and 2. In B, the domain is -1, 0, 1, and 4. That's the x values. And the range is if I go smallest to largest, which again you don't have to, but -3, -1, 1, and 2. Okay, so that's how you do it with a table. Now, if I have a graph, to decide if it's a function, I still have to test if each input produces only one output. And what I do for that is I use something called the vertical line test. So the reason we use a vertical line test is, for example, in C, if I look at an input of 2, which is right here, I can see that I have 2 points with an input of 2. This point is the point 2, 2. This is the point 2, -2. So an input of 2 is producing two separate outputs, and you can see that by drawing a vertical line through the graph, and the vertical line hits in more than one point. So if you can ever draw a vertical line that hits in more than one point, it's not a function. If you look at D, no matter where you draw a vertical line, those vertical lines are only hitting in one point, so this is a function. And in E down here, I see that no matter where I draw a vertical line, that vertical line is only hitting in one point, so this is also a function. So that's from a graph to test if it's a function. Now let's talk about domain and range. Domain and range are again, the list of x values and the list of y values, respectively, that appear on the graph. And what you want to remember is that when we say the x values, you've got to remember that this graph has an infinite number of points on it. I can't draw them all in, but for each one of these little dots, there's an x value. And it goes all the way, well, it goes forever. So if I'm looking for the x values, what I'm thinking about is how do I describe the x coordinates of all of these points that I'm drawing in here, and knowing that every time I put one I can always find another one in between the other two. Well, what I like to think of is, can I build a wall on the left or the right of the function or the relation that the graph will never pass through? For example, in this one, I could put a wall right here, and that graph touches that wall at, I think that's a value of 6, but it never crosses through that wall. On the other hand, let me put 6 down there. If I tried to put a wall over here on the left, and the reason I'm using walls on the left and the right is that the x direction goes to the left and the right. No matter where I try to put a wall, this graph is always going to pass through that wall. So there's no wall that I can put on the left, but there is a wall that I can put on the right. So the x values that occur on this graph are all x values that are less than or equal to 6. So this is the domain. Let me look at the domain for part D, and then I'll come back and get the range. Well, in D, if I tried to build a wall on the left or a wall on the right, no matter where I try to put that wall, my graph goes on forever. That's what those arrows mean. So because my graph goes on forever, there's no wall that I can put on the left that can trap my graph, and there's no wall that I can put on my right that traps my graph. So that means that every single x value appears on this graph. So the domain here is all real numbers. And similarly in E, these arrows here mean that this graph widens out forever to the right and forever to the left. So the domain here is all real numbers. So when you're thinking about domain, you're asking yourself, is there a boundary in the x direction that can sort of trap the graph on one side of the boundary or the other, or maybe between? Now, before I move on to range, let's talk a little bit about interval notation. If you want to write these things in interval notation is something that doesn't use a variable, and it doesn't use this less than or greater than symbol. What it talks about is what's the left-hand boundary and what's the right-hand boundary of your graph. And if it goes forever to the left, then that's negative infinity, and forever to the right is positive infinity. So if I write the interval notation for the domain here, the left-hand boundary for this graph, well, there is none, goes forever to the left, so that's negative infinity. And the farthest that it goes to the right is 6, so I put comma 6. And then you either use round parentheses or square brackets. If you actually get to the point, then you use a square bracket. If you never get there or never touch it, then you use round parentheses. So infinity is something that you can never really get to, so we use round parentheses on that. And the 6 we actually do touch, so I'm going to use a square bracket there. When the domain is all real numbers, it means it goes forever to the left and forever to the right. So the interval notation for that is negative infinity to positive infinity. Okay, now let's talk about range. If looking for domain and x values was looking for a left-hand or right-hand boundary, then looking for range is the y values, which is an up and down boundary. And so if I talk about walls being part of the domain, then when I'm looking to see what the range is, I'm asking myself, can I put a floor or a ceiling around this graph? So for example, in C, I'm asking myself, is there any way that I can put a floor on this so that this graph never goes below that floor? And can I put a ceiling on this graph? Is there a way to draw a line horizontally so that the graph never crosses through that ceiling? And in this case, because this graph keeps getting wider and wider and wider the more it goes to the left, there is no floor and there is no ceiling. And just like we did on the x-axis where we put these infinities here in the negative and positive direction, we do the same thing on the y-axis. So the range in this one is all real numbers. And if I were to use interval notation, the floor is negative infinity, the ceiling is infinity. Because I never really get to either of those, I use the round parentheses. For D, if I'm looking for a floor or a ceiling, for D, again, for the ceiling, I don't think I can put any ceiling here that this graph won't go through because it goes forever up and to the left and up and to the right. But there is a floor here. There's a floor right here, and the graph is pretty tiny, but that's actually a y value of -4. So if I look at where the graph is always above -4. So my range, if I use an inequality, is y values that are greater than or equal to -4. If I use interval notation always goes from lowest to highest. So the lowest y value is -4. The highest y value is infinity because it goes forever up. I never get to infinity, so I use round parentheses there. And I do actually touch -4, so I use square brackets there. And for the last one here, E, if you think about a floor and a ceiling for the range, you can see that those arrows say that this graph is going forever down and forever up. So there is no floor and there is no ceiling that I can put around this graph. So the range is all real numbers. And again, if you want interval notation, that would be -infinity to +infinity. So this first part of our video reviewed how to determine if something's a function, whether you're given it in a table or a graph, and how to find the domain and range from a table or a graph.